We're here with Dr. Chung-Hoon Lee, and he's going to explain to us this part of the circuit. Here we go.
Okay, so this is just a buffer, and we're going to draw a virtual ground and also a positive and negative rail from a 9-volt battery. So how we're going to do this is we're going to put a ground, and this is going to be our virtual ground from now on, onto the output I mean. And so by putting it on the output, the negative rail, the negative input becomes virtual ground as well. Since this is a feedback loop, what ends up happening is the positive input becomes the same voltage as the negative input, which means that this node over here is 0 volts. However, this is a 9-volt battery, but it's not as if this resistor is going to be 9 volts. It's going to be 4.5 volts since these resistor values are the same. So that means that this is going to be 4.5 volts, the voltage drop over this, and then the voltage drop over this is going to be 4.5 volts as well. Since this is 0, this is going to be 4.5 volts positive, and that means that this is going to be the positive 4.5 volts rail, and that's going to go into our positive rail. And then this is going to be our negative 4.5 volts over here, and that's going to go into our negative 4.5 volts rail, and that's going to be our buffer where we can draw a virtual ground from.
And here we have Dr. Seye, who will present the most complicated part of the circuit here. Take it away.
So we start with our transmitter. We have a summing amplifier. We have two parts we're looking at. We're looking at our microphone part and our audio in. The microphone's a bit more complicated. We have to actually amplify and eliminate some of the signals we don't want. We have to really isolate an AC signal, which is your voice. To do that, we first use a voltage divider to actually be able to get the signal out of the microphone. What's happening is the voltage at this point will change as you speak into the microphone. We then AC couple this voltage, or signal, using this high pass filter here. Then we feed it into an amplifier here that runs off a rail split voltage, 4.5 to negative 4.5, which allows us to feed an AC signal into it. We have a gain of about 101 total, and we take it through here. And so at this point, the signal has been multiplied by 101. We feed it through another high-pass filter. Then we get to the main summing circuit. This is where it ends right here before we add the audio signal. We mix, or we quote-unquote mix the signal. Right now, it's being multiplied by negative 1/2 when it goes to this amplifier. Now we send in our audio signal through our high-pass filter, and it goes through the same process. It gets the same gain attached to it. So now everything is at this point here. So we sum together, and the whole thing is basically attenuated by negative 1/2. It's inverted and cut in 1/2. Then we push, and that was for the purposes of making sure we don't oversaturate the amplifier, because a typical audio signal peak to peak is around 2.1 to 2.5 volts, depending on the device. Usually it's about 2 peak to peak, but it can change. We also have we have a large capacitor here to allow a lot of current to go through. His reactance is pretty low at a given frequency spectrum of 20 to 20,000 hertz, which is what we want. And then we're using a bias T, which just allows us to remove or add an additional DC component to this laser. So we're actually biasing the laser when nothing is on by 4.5 to keep it on, because we don't want the laser blinking. We want to actually modulate it. So we want basically the current, we want the voltage like this, but we want the current to change, which means the intensity of this light is constantly changing. And we have two 100 ohms here to allow for more current to come in without exceeding the 25 milliamp max on the LED. And that, after the signal is produced, after you put your signal in, it's transmitted to our receiver, which will be explained by Dr. Pan in the next episode.
Greetings. I will now demonstrate the receiver circuit here. We start with a solar panel. One side is wired to the virtual ground, and the second side runs through a high-pass filter. And the reason we use this capacitor here is to pass through AC coupling, and the point of it is to remove the DC part of the current that runs through. So initially it's offset at a higher level than it should be, but once we remove that DC component, we're left with just an oscillating voltage which can run through the rest of the circuit. Great, and now we're going to move to the non-inverting amplifier used here. You see the rails are 4.5 volts, negative 4.5 volts, with a gain of 91. The calculations are right here. And after that, we use a capacitor at the other end, the output side, to draw the current out and into the speaker. 8-ohm speaker at negative 4.5 volts, wired on the other side. Cool.
Oh, wait,
We're here with Chung Hoon. He's gonna play us some.
It's just some good
It's
old
straight out of
NWA.
Compton. Yeah, you wouldn't think, but here we go. So we have it placed right here. The
Here's our
laser's
laser.
shining right over there. You might recognize this room as the office hours room. We're gonna move on over to the receiver circuit. As you can see, we have this passive speaker wired into our receiver circuit. You can hear said music coming loud and clear, and it can be interrupted by me placing my hand in front of the laser, like so. Pretty cool. Pretty cool. All right. Wired here by a 9-volt battery.
Hello,
Oh,
can you hear me?
I can hear you, Chung Hoon. Could you say that a little louder so we can hear it through the speaker?
Hello, can you hear me?
Yes, we can. Excellent. Oh, is there another part we need to test? Probably not, right?
Yeah.
We good. We good. We're now in the hallway outside of the office hours room. This is Chung Hoon. Playing the same song from YouTube as before. We are wired the same exact way. We're gonna demonstrate how far this thing can go to a passive speaker now. Let's make our way down to our microphone engineer, Anthony. Oh, he is just loving the music. Oh, and that's our professor. That's pretty cool. Okay. Here's wired to the passive speaker again. Anthony, how you doing? Wired the same exact way. As you can see, the laser is a little more dispersed than before, not as concentrated, so definitely is leading to a change in the sound. But Chung, could you say something into the microphone, please?
Hi, can you hear me?
We can hear you.
Good.
He's currently whispering into the microphone, so we would not be able to hear him otherwise, but that's pretty cool. All right, excellent. All right, yeah. This is from a pretty big distance. As you can see, we're in the student union. This is the ballroom, student union ballroom, 3rd floor. We're right about where the doors are, and that's all the way by the windows. We're currently playing Mercy by Kanye West. We have Anthony here. He's gonna be our microphone engineer. He's gonna be speaking into this here microphone, which is projecting on this laser pointer. And I'm gonna run all the way down and see if we can hear him. All right. Here we go. There you go. He's ready to go. He's ready to go back there. Here I go. We got the speaker set up in the receiver circuit.
I'm doing good.
Right here. And that is the solar panel.
Can you hear me?
I hear you loud and clear, Anthony.
It's good. It's
Wow, wait.
good. You hear that?
That's so sweet.
That's the sound of science right there. I'm the sound of science,
Can
yes.
we hear the music though? Let's turn it up a little bit. Oh, actually that's maximum volume. Andy, can you turn the volume up a little bit?
Yeah, I just did.
Oh, that's it?
Yep.
You know, it's a long distance. Oh well. Pretty cool that it works from this far though. Yeah, wow. That dude, your voice is loud and clear. Sweet. Yeah, no, it's very comfortable. It's almost like you're a DJ speaking into a microphone. All right, sweet. Yeah, that's this clip. We're back with our microphone engineer, Anthony here. We're gonna work our way back to this. As you can see, we've moved it a little bit closer than last time, and hopefully we'll see some changes. This time, we're playing Jai Wolf's remix of The Weeknd by Maki. Here we go.
Yeah, you guys can listen to it over here. I mean,
Oh, yeah.
I'll speak in here yet again.
Yeah.
As I usually do, and Eric will go over there and show you guys.
Of course. All right. So last time when the when the transmitter circuit was really far back, we didn't really get that loud of a sound. But as you can see now,
Yeah, we're doing much better now.
yeah, I mean it's a lot more clear.
And crisp.
It's marginally louder actually. It's not that much louder, but the signal or the laser, as you can see, is much more concentrated. It's not as spread out as before. You get a much clearer signal. Still the 9-volt battery. Same circuit as before. Just moved it closer. Yeah. Just yeah, say something cool. And say something cool in the microphone.
Yeah, something really cool. I haven't got anything. Sorry.
Oh, he's got nothing. All right. We'll be back with the next installment soon. We're back with our microphone engineer, Anthony. That's him. What song are we playing today? Let's just start this one over. We're gonna play All I Want by Don Golden, the Manila Killer remix. Here we go. So as you can see, we've moved the circuit much closer to about 1/3 of the distance that it was before. We're gonna see the changes that are happening. So as you can see, we've actually directed our speaker towards the rear, and the reason for that is when we had it facing our transmitter, there was actually considerable feedback. The sound now is a little bit louder, and the fact is that it's actually at half volume. So what we can do is turn it up, but then what we're gonna hear is a lot of feedback. So let's try it. And there was the feedback. So this just shows that as the signal is much more intense, it can create a louder sound, but it does become saturated at a certain point. I approve. He approves of the message. All right, we'll be back with the next clip soon.